In this final video, we're actually going to cover what's probably going to look like two different worksheets or assignments you'll get in class. We're going to first focus on how can we just straight up get rid of fractions? Because when you get into Algebra 1, and especially moving forward into Geometry and Algebra 2, you're not going to want to see fractions and equations. Getting a fraction as an answer, that's fine. But you do not want to have to spend time working with fractions. And there is a way we can get rid of them. And it's exactly what it says. Multiply the equation by the LCD to eliminate all fractions. Now there's one big major caveat before you can do this. No mixed numbers, which we've been pretty much eliminating anyway. The best way to handle fractions in an equation is to strictly have fractions. Mixed numbers just cause headaches. So the first thing we're going to do, if we have an equation that has mixed numbers in it, we are going to unmix them. We're going to make them improper. So in number 13, that means I'm going to keep the x, I'm going to keep the 1/2, but the 2.5, I'm going to convert. 2 times 2 is 4, plus 1 to make 5/2. Now, look at our fractions. They both have denominators of 2, which means our least common denominator is 2. My directions say multiply the equation by the LCD. So we're going to multiply the entire equation by 2. And notice this is all we have to do. We're not told to solve. Right now we're just eliminating the fractions. Now this is distribution. Been a while since we've seen that. This is saying, okay, I'm going to take that LCD and I'm going to multiply it to every single thing in the parentheses. 2 times x. That's nice and easy. That's 2x. 2 times 1/2. That's 1. 2 times 5/2. That's 5. Done. When the LCD is just the denominator of the fractions, then anything that's not a fraction does get multiplied by that LCD. But multiplying a fraction by its own denominator will simply clear out that denominator. Will every problem be this nice? No, of course not. But this is the general process we're going to follow now. And that's all we're doing in these first 6 problems. We're multiplying the equation by the LCD to get rid of the fractions. For number 14, we've got ourselves some mixed numbers, so time to unmix them. 9 times 5 is 45. 45 plus 8 is 53/9. 53/9 are equals, oh boy, those are some numbers. As usual, in the interest of saving some time, I'm going to grab a calculator and do 27 times 9. That is 243. And then I'm going to add my 22 to have a fraction on the right-hand side here of 265/27. So we've got two fractions. They have denominators of 9 and 27. What's the least common denominator if I'm working with 9 and 27? Well, since I can turn 9 into 27, the LCD is 27. So here, we do have one fraction that will simplify very nicely. That's the 265/27. And we've got one fraction that doesn't simplify quite as nicely. Now you might be thinking, does this really mean I have to do 27 times 53 and then divide whatever that is by 9? That's one way. That's one way to figure out your first fraction. I wouldn't recommend it. Instead, and let me show the distribution here real fast, throw my arrows down. Here's how I mentally approach doing something like 27 times 53/9. Okay. Here's the reality of this statement. I don't have to do the multiplication first. I can shift that denominator to the 27 to do the math. 27 divided by 9 works very nicely, and that's kind of by design. That's why we chose 27. We knew it would play well with 9. Now I'm just doing 3 times 53. That's nowhere near as bad. 3 times 50 is 150, and 3 times 3 is 9. So again, the process that I use is instead of multiplying and dividing, I divide. 27 divided by 9 is 3. Then I multiply. 3 times 53 is 159r. On the right side, I've got a fraction with a denominator of 27. Then I'm multiplying by the whole number 27. That means the fraction just cancels. We're left with only the numerator of 265. Done. In number 15, there's actually no conversions we need to do because there's only one fraction. So we can just straight away say, okay, I'm going to multiply this entire thing by the denominator of the fraction, which is 3. We have to give that 3 to all the pieces inside. So 3 times n is 3n. 3 times -1 is -3. And when I multiply 1/3 by 3, since I'm multiplying a fraction by its denominator, I'm left with the numerator, which is -1. I invite you to pause and try 16 through 18, and then come back and see 19 through 22. Number 16. Again, fractions are already fractions. There's no mixed numbers. So we can go right away to saying, okay, denominators are 3 and 21. So my LCD is 21 because I can turn 3 into 21. Now, not forgetting that that 21 is going to be handed out to all the gentlemen inside the parentheses. 21 times A is 21A. 21 times -2/3, so we're going to have subtraction. This one is not the super nice, where it just cancels the denominator. But this isn't bad. Remember my process. 21 divided by the denominator, so 21 divided by 3 is 7. Take that 7 and multiply it to the numerators 2. 7 times 2 is 14. On the right side, multiplying a fraction with a denominator of 21 by 21 does just clear the denominator, leaving the numerator of 79. In number 17, again, no conversions are needed here. We can get straight to looking at the denominators of 5 and 45. We can turn 45 or 5 into 45, which means 45 is the LCD. We're going to multiply all the parts of our equation by 45. So 45 times r is 45r. We are going to have minus. And now we have to stop for a second and say, okay, 45 divided by 5 is 9. 9 times 6 is 54. On the right-hand side, the 45 will cancel the denominator, leaving us the numerator of -79. Number 18 finally does require conversions. So on the left-hand side, we're going to have 9/2 x. On the right-hand side, we're going to have -18/5. And for the first time, we have fractions that have different denominators, and neither one of them is the LCD, because you can't turn 2 into 5. So what's the smallest number that 2 and 5 will agree to become? Well, that's 10. Our LCD is 10. We give that 10 to everybody in the equation. There's only 2 parts here. And this requires our trick on both parts. 10 divided by 2 is 5. 5 times 9 is 45x. 10 divided by 5 is 2. 2 times negative 18 is negative 36. Now what's nice about this is if we do this, as you can see, we no longer have to deal with fractions as we work. We'll probably still get a fraction for an answer, but that's only seeing one fraction at the very end. So my last 4 examples here are actually using this process to solve some equations. So let's take a look here. Number 19, step 1, I do not like the mixed number. Step 2, multiply everybody by the LCD, which is 9. Step 3, actually do the distribution. 9 times v is 9v. 9 times negative 2 is negative 18. And 9 times negative 11 ninths is negative 11. It just clears out the denominator. Now I'm going to copy that. 9v minus 18 equals negative 11, because now we have a 2-step equation to solve. Our first step is to add 18 to both sides, getting us 9v equals positive 7. We then divide both sides by 9. And our answer is that v is equal to 7 divided by 9, 7 ninths. We can't do anything to that. 7 divided by 9 is 7 ninths. Done. In number 20, notice something. Denominators are identical. If 2 fractions have the same denominator and they're equal to one another, then they must also have the same numerator. The numerators must be equal to each other. We don't need any of our tricks, although we can use them. If we think about how fractions work and how an equal sign works, we can immediately take this problem and say, hey, both denominators are 23. I know these fractions are equal to one another. So if their denominators are exactly the same, their numerators must be exactly the same. Set them equal, do a quick solve. M equals 2. In number 21, let's convert. So 9 times 2 is 18. 18 plus 8 is 26 ninths. P equals 63 times 7. That's going back to calculator time. 63 times 7. That is 441. Plus 1 is 442. Now, thankfully, 63 is a multiple of 9. We all know that's 9 times 7. So, when we try to clear out the fractions, we can use 63 as our LCD. For the first fraction, 63 divided by 9 is 7, and 7 times 26. So 7 times 20 is 140. 7 times 6 is 42. 140 and 42 gives us 182p. The right fraction, we're just dividing 442 by 63. Sorry, that's not what I intended to say. We're multiplying 442 over 63 by 63, so we are just getting rid of the denominator, and we have 442. Divide both sides by 182. P is equal to 442 over 182. This can be simplified. This can be converted to a mixed number. I just want to check something real fast. So bear with me 1 second. 442 divided by 182. Yeah, I didn't think this would be too awfully nice. So what can we do here? We can divide both of these by 2. And that becomes 221 over 91. Then we can take 291s away from 221. 291s have a value of 182, as we know, from above. So 221 minus 182 gives us 39. And 39 is a prime number. It doesn't go into 91. So the final answer is 2 and 39 91sts. Now I do apologize, but I'm going to have to erase that because I need this space to do number 22. So 2 and 39 91sts is the answer to number 21. For number 22, we do need to do a quick conversion. So that's going to get us 15 sevenths n equals 75 28ths. Our LCD is 28. We can turn 7 into 28. When we distribute, 28 divided by 7 is 4. 4 times 15 is 60n. On the right side, we're multiplying a fraction with a denominator of 28 by 28, so we just have the 75. Now just divide both sides by 60 to get n equals 75 60ths. We can convert that by taking 60 away from 75 to turn it into 1 and 15 60ths. And then we can simplify because 15 and 60 will actually both divide by 15, giving us a final answer that n is equal to 1 and 1/4.